Hello and welcome to Doc Clay's chemistry lessons. Today we're going to be looking at atomic structure and electron configuration, importantly. So by the end of today's lesson you should be able to recall the maximum number of electrons in a given shell, work out the number of electrons in an atom or ion given its atomic number and charge, and describe the electron configuration of an atom or ion in the first 20 elements. Let me just point out for anyone who's watching this video that this is true for GCSE level, and our electron configurations, if you're doing the A-level course, are slightly different. So make sure you don't watch this video if you're doing the A-level course. So we know from our atomic structure work that atoms are made up of protons and neutrons, which exist in the nucleus, and then the electrons that are around the outside in what we call shells or orbitals. We've also seen that in the periodic table we have information, and it's given to us in this way. We have a symbol which states basically the number of protons that there are in the element. We have the atomic number, which tells us how many protons there are in that given element. We have the mass number, and this is the number of protons plus neutrons. Atomic number there is the number of protons. And we also have the charge. And the charge tells us how many electrons we have compared to the number of protons. Remember here that a proton has a relative charge of +1, while the electron has a relative charge of -1. Therefore, if we have the same number of electrons as we do protons and it's neutral, zero charge, and we call it an atom. If we have different numbers of protons and electrons, then we have a charged substance, and we call that substance an ion rather than an atom. So, first to working out our number of electrons. This is true for any atom or ion. The number of electrons is equal to the atomic number minus the charge. Let's just look at that for our example here for sodium. So our number of electrons in our sodium 1+ ion is equal to the atomic number, which is 11, and it's got a charge here of 1+. So we take away +1, giving us, in this example, 10 electrons. We give another example. Perhaps let's look at lithium as an atom. Well, this time we'll say lithium has got a proton number, an atomic number of 3. There's 0 charge, so we take away 0. So there would be 3 electrons in that example. Let's take a final example with fluorine, but we'll take a charged example of fluorine, so we'll have fluoride, we've got a 1- charge. So in this example, fluorine's got a atomic number of 9, we've got a -1 charge, so it's -1, which gives us a positive value. So again we have 10 electrons in fluoride. How are they arranged? Well, here is, we look here, we've got our model of the atom. We've got the nucleus, which is very small and in the center there. Just label that. We then have the electrons going around the outside. We're only going to worry about the maximum number of electrons in the first 3 shells. maximum number of electrons. And in the first shell, I'll draw them here as crosses, we can have 2. In the second shell, I'm going to draw them paired up. We can get up to 8. In the third shell, we can also get up to 8. That is in the first 20 elements. Calcium and potassium both come in shell 4, but we'd only get up to 2. So we don't need to worry about the maximum number of electrons in shell number 4. Let's just move on then and take this a bit further to look at a couple of examples. We've got here boron, and if we check our periodic table, boron, the smaller number of the two, has got a atomic number of 5. And if we're looking at boron as a neutral atom, the number of electrons therefore is going to be 5 minus 0, gives us 5 electrons, and they fill up in the first shell first. So we have 2 in the first, which is now full, and then we can put 3 in the second shell. How we write that as an electronic structure? Well, we write the first shell first, so it's 2, followed by the number 3. Each number long indicating the number of electrons in that shell. Next then, magnesium. Well, if we look for the atomic number of magnesium, you see it's next to sodium there. It's 12. Then we fill up, or we check how many electrons first. We've got 12 minus 0, giving us 12. So we fill up, we've got 1, 2, that fills our first shell. We've got 10 electrons left to put in. So we put 1, 2, 3, 4, 5, 6, 7, 8. That completes the second shell. We've now got 10 electrons in. We then move into the third shell, which is the next one out. We put 2 electrons in there. Our electronic structure, therefore, is 2, 8, and 2. This outer shell, or the electrons which are in the outermost shell, we call these the valence electrons. And the valence electrons, or the number of valence electrons, is the same as the group number. So the number of electrons in the outer shell or valence shell equals the group number. And that's quite a handy thing to remember, particularly when we're moving on to things like bonding, ionic and covalent, and metallic in due course. The only final example we didn't really look at there was if we had a charged species. Well, let's have a look then. Let's imagine we had magnesium with a 2+ charge. The atomic number would still be 12. The number of electrons would be 12 minus +2, giving us 10 electrons. That's 1, 2 in the first shell, 1, 2, 3, 4, 5, 6, 7, 8 in the second, and the structure would then be 2, 8. We would then have some square brackets, and a little +2 just to show the charge. If it was a minus charge, we would just have a minus charge on the outside of the brackets. Okay, so having watched our lesson on atomic structure and electron configuration, you should now be able to recall the maximum number of electrons in a given shell, work out the number of electrons in an atom or ion given its atomic number and charge, and describe the electron configuration of an atom or ion in the first 20 elements. That's all for now. I'll see you soon.